Hello, ladies and gentlemen of geometry. This is Mr. Heeren coming at you virtually because that's kind of the only way we got to do things nowadays. Today, we're talking about your area of a circle and the area of a sector of a circle. So I want to start with this. Just the area of a circle is not too difficult. So you see over here, we've got this circle, and that R stands for your radius, and all that is the distance from the center to the edge of the circle. So the area of a whole circle is going to be just pi r squared. So that's your radius times your radius times pi. Okay, that one's pretty straightforward. Your radius times pi. What isn't so straightforward necessarily is how do you figure out the area of a sector? Now, a sector is this part right here, okay? So you're looking for an actual space. All right, that's what that is. You're looking for a space, but it's not the whole circle. You're only looking for part of the circle. So the way we do that is we use the angle measure that is associated with that space right there, okay? So, you know, I kind of messed it up a little bit. I apologize for that. It says right there, x degrees, so whatever that is. So what I'm going to do is I'm going to take x degrees out of a whole circle, which is 360 degrees, and I'm going to multiply that times the area of my circle. Okay, so now let me just explain kind of what I did there and why that works. That works because this is the area of the whole circle. And what this does is this limits my area to just the spot I want. Limits it to just the area I want. All right, that's what I'm looking at. So I want to take my area and just the part of it that I know. So that's kind of what I'm looking at here. So if we look, find the area of the shaded sector. See that shaded sector is 148. My radius is 6. All right. So the way that works is I want 148 over 360 because that's the part of the circle I'm dealing with. And then I'm going to multiply that times 6 squared pi. So if you throw it all in the calculator at once, you're going to be in trouble. Okay, so 148 divided by 360 is going to be 0.41 repeating. All right, so then you're going to multiply that times 36 pi. And what you're going to get is 46.5 meters squared. That's the area of just this shaded part right here. That's all I'm doing. Take your angle over 360 multiplied by the radius squared. All right. So over here, you notice I have a significantly smaller amount. All right. A significantly smaller amount. But so my answer should be small. So I'm going to take 53 over 360, multiply it times 4 squared times pi. Okay, so 53 over 360, 0.1472 times 16 pi should give me 7.40 feet squared. So now if you take a look at this one's a little bit different. So it tells you this amount is 65, but this other stuff is the shaded part. Okay, so here I got to do a little thinking here. So I want the shaded part, but they only tell me the unshaded part. So what I got to do is take 360 minus 65, and that's going to equal 295. So I want to use 295 over 360 times 11 squared pi. So when I do that, 295 divided by 360 is going to be 0.8194, repeating, times 121 pi. All right, so if I take that times 121 pi, I'm going to get 311.497 inches squared. That's going to be my answer. All right, so again, all I did, I took 360 minus 65 because that is my shaded area. That's the area I want. All right, then I took that and put it back in here. So the big idea is whatever your angle is divided by 360 times the area of the whole circle. That's going to give you the part that you want. Okay, so here they tell you this is 130. This is 130. That makes this also 130. So that makes this 50. That makes this 50. Why? Because the entire circle's got to add up to 360. So if I subtract 130, subtract 130, I get 100 divided by 2 makes that 50. My radius is going to be 3. So what I want is these two combined. So what I can do is I can take 50 over 360 times 3 squared pi. So I'll take 50 over 360 times 3 squared pi. What I will get is 3.92. Now, that 3.92 or 3.927 is just going to be one of these little things. It's going to be one of those little pie pieces, pizza pieces. So then if I double it, that's going to be 7.854. Okay, so I got to take that times 2 because there's 2 of them. So that would be the area of just my shaded part. But now, what's the question asking? Question's asking for a probability. So all I do for that is I take the shaded part over the whole thing. So I've got the 7.854 meters squared. And I want to divide that by the whole thing. So all I do for that one is just take 3 squared times pi. So that's going to be 28.27. So I can just leave this as 7.854 over 28.27 and call that good. Or I can actually divide it. When I actually divide it, dividing those 2743, you get about 27.278 or about 27.8%. Okay, but the difference is you just put your shaded over your whole. So if you can do that, then you're going to be fine. All right, so what if my probability of landing in the shaded area? So the whole thing is 9, which means if I cut it in half, my radius is going to be 4.5. Then they tell you that these two lengths are the same, so I have to divide that by 2. I get 2.25. All right, so the radius of this whole thing is going to be 4.5. But they just want the shaded area. So here's what I'm going to do. I'm going to take the area of the big circle and subtract the area of the little circle. How do I know the difference? The radius here is going to be the full 4.5, and the radius of the little is going to be 2.25. Now, one thing that kids seem to think, and kids kind of jump to conclusions that, well, if the radius, if 4.5 is twice as big as the radius, then the area should be twice as big. Well, that's not necessarily the case when you're talking about area. Lengths have a ratio of one ratio, areas have a different ratio. So you can't do it like that. So all I'm going to do is take 4.5 squared times pi and 2.25 squared times pi, and I'm going to subtract them. So 4.5 squared times pi is 63.617 minus 2.25 squared times pi is going to be 15.904. So if I subtract those, (47.712 centimeters squared), that is going to be the area of the shaded part. All right, but now again, they're looking for probability. So the probability of landing in my shaded area is just going to be the shaded area over the whole circle. So all I'm going to do is take 47.712 and divide it by the area of the whole thing, which was this. So 47.712, which is going to be 0.75. So there's about a 75% probability that if I throw a dart or whatever it is, I'm going to land in this shaded area. That's what I'm looking at. Okay, so your homework is, some of you guys picked it up on Monday on the paper copies, but I want to look through it once. So here's what you're looking at. So do both of those. See if I can shorten this up a little bit. So skip 19 and 22. All right, you can skip those two. Don't do those. You can skip 24. And then try 32 and 35. Okay, I want you to do those. So we're skipping 19. So no 19, no 22, no 24. You can do the rest. All right, if you have any questions, please reach out to me. Also, take a look in Schoology. I'm putting a lot of information there, and there's a lot of different ways that you need to kind of be able to connect with me.